Right, I think we can proceed. Right, so basically we are discussing the operating system, especially for from the beginning. So up to now, we discussed the main components of operating systems and the role of the operating system and other stuff. So initially, we divided into mainly operating systems and the application softwares, and the softwares are categorized into mainly two categories. Then we discussed a little bit on operating systems stuff, and we have given a definition, right? And simply, you might should understand now, an operating system is just the enabling power of this dumb hardware device. So basically, it might be your laptop or a desktop or the machine that you are using. So operating system provides this power to this hardware device to be or a workable product. So basically, we can interpret an operating system as an interface between user and the hardware, because whenever we want some sort of activity which can be processed or used, which can be worked in operating system, what we do, from the computer. So what we do, we just provide some sort of commands. It might be a button press or a mouse click. These are the activities that we are providing commands. These are the activities that we want to do, and returned by the operating system. All right, this is the stuff that I can do. And basically, you should understand always the operating system lies on top of the hardware layer. What is this hardware layer? It's just your computer, your desktop or something. And basically, different types of operating systems like Ubuntu, Windows, Mac, and other stuff is there. So again, what's an operating system? There are many definitions of there. Interface between software, between computer and the user, software that manages the hardware, right? So there are more definitions, right? So what are the resources and other stuff? We discussed those things. And here you might see the overview, or actually where it locates. So you might see this is the operating system, and here the processor and memory, file systems, IO devices. We are supposed to discuss all of these things. And here the application softwares. What are these application softwares? It might be Windows, Word, Excel, or web browser, these kinds of things. And here the user interface, in generic terms, you might see it's just what we call desktop, or your interface that you are interpreting, you are interacting. There are many mediums available. We'll discuss one by one later on. And here the uses. Right. And functions of operating system, we discussed process management. Up to now, we completed all the stuff apart from a small component remain. Nearly 1 hour, I'll take it. Last time it was missed from my end, sorry. And definitely next week, probably, yeah. All right, upon your preference, next week we can complete that 1 hour time. So probably usually we are using 115 to 415, so we can extend to 115 to 550. I'll give a small break. I know it's 4 hours is quite hard, so if not, you may suggest a suitable date and time. I can join or reset up. And here the memory management, that's the main focus for today. And there are remaining tasks like file, disk, IO disk, user interface, device management, system security, performance and error handling. So these kinds of things we're supposed to discuss. And process or the process management almost completed. You know what is a program and what's a process now. Program versus process. and some sort of terminology like program, process, instance of others. Right, thread. Right. And we proceed a little bit further for discussing a story of a process, how the process is accessed at different places, and we have used this process management or the high level of process states. So basically what happens in process states, whenever process requires to process, it's a new process, and it moves to the ready state, it's mandatory. Then mainly it's dispatch the running state. This is the place that execution happens. After, there are different options available. If the process is completed, it can move to dead state or the terminated state, or it can move to the event wait. So usually why it moves to event wait? Because of some sort of resources missing. That's the wait queue, or resources required to be a resource is required to execute, or it might be timeout. So last week I clearly discussed about this timeouts story, what is happening in this timeout, and why there's a timeout. So these are the major three paths that a running state can be moved. In the other hand, there's a possibility whenever something in a wait queue and the resources are fulfilled. As an example, if you want some sort of data packet, we are watching a YouTube video, right? I'm telling some sort of real world story to understand what is this resource requirement. This is not the operating system, some example to get understand what happens in here. So whenever you are watching a YouTube video, stream of data should be coming to your computer. So this is your desktop, and the movie something is playing in here. Every time it should send this set of data or packets of data, unless it would not move or it's not simply. So each time it waits for a while until the data packet arrives. Then only the small bar that you can see, there's a small bar filling time to time, like little bit. So it's a process, right? It's a process. You can map this story with this process waiting. And if there's sufficient data packets arrived, it can play again. I think you got this process management for the process state diagram. But if you have any questions nowadays at all, you can stop me in any given time and ask any question that you got. It might be a very simple question, or it might be a very complex question. It depends. Though it's an easy question or a hard question, it's not a problem at all. You may ask if you really fear to. You are really upset to ask question by switch on your what you can do is individually ask from me. No worries at all. I don't get upset at all. So you can chat with me and ask whatever the question that you ask. And on the other hand, as I told you, the subject is quite confusing and quite complex. So you should give maximum effort to understand in and out on this. At the beginning, I don't think so. The first time, if you are hearing all of this in the first time, it's quite confusing and quite complex. To avoid these confusions, the best thing is you should go additional materials. Probably YouTube is one of best source to learn, and there are different other sources available. Whatever you prefer, it might be an ebook or a tutorial or whatever. You can go through and understand well. So process management is part of operating systems, and processes are kept in queues based on their states. Scheduler decide which process moves next, or what is the process that should be run in next time. And I told different algorithms available. According to the algorithm, it might be executed. And this is the story of allocated time run out or timeout. In a given process, there's a specific time. After that time, that process should move back to the queue. These are two different cases. Resource because of resource scarceness, a process can be halted. In the other hand, there's a situation that process is running, and because of timeout, it moves to the ready queue again. So these are two different stories. Don't confuse these two situations happen in the process. And they might be blocked because of some sort of IO event waiting until it responds. So interrupts between the interrupts are often used to let operating system when event process is waiting for has so device ready. Right. Well, this is the process management which is happen in the beginning, and I think I need to discuss this one if I'm not mistaken. Did I discuss this? Did I discuss this or not? No, right? This is the place that I stopped last time, and I'll take that 1 hour probably next week or even today. That's okay for me. You may decide. There's a representative. You may please have a chat with your friends and let me know what's your preferred method, or I can open a poll that you can join. You can share your preferences. I'm okay with today or next week or any other suggested day that you prefer. It's not a big deal for me. We'll discuss these two, like what is this deadlock and other stuff, how these are happening. So we'll continue to the today topic, which is memory management. Before starting memory management, I would like to get some understanding what you know related to the memory management. Do you know what is RAM and ROM? Or if you don't know anything, at least what is a RAM or ROM or something, because I can tailor for you. If you guys don't have any idea what is this RAM or ROM or right, secondary memory, primary memory, those stuff, then I can tailor it for you. No worries at all. If you know, I can start from some sort of not a beginner, a little bit intermediate level. If you are well, I can start with some sort of advanced concepts even. If you want, I can do whatever the level that you want. Yeah. How we can confirm this understanding? We'll have a set of questions. All right. Well, we'll have a question. So give me a second. I just want to take. Sorry. All right. I got a request, so we'll try. I have shared what we call Google Form. Could you please quickly uh, give your insights? If you don't know, no worries at all. You may tell, I don't know. That's it. Don't take a lot of time. Just quickly answer. I think very basic questions. If you don't know any, you just tell, I don't know. That's it. Secondary storage means your hard disk. Usually 1 terabyte hard, your C drive, D drive, and other stuff. You have to sum up them. As an example, if your C drive is 500 GB and your D drive is 500 GB, then your secondary storage is 1 terabyte. Still, I got only 7 responses. Actually, no worries at all. It's anonymous. So that's okay. If you don't know, just tell, "No, I don't know," because I know you people are just beginners. Because if I'm trying to explain some advanced concepts, Without knowing the basics, it might be a big problem for you. Yeah, I'll come to virtual memory. What is virtual memory and other stuff? I'll teach you definitely, because I know as per the responses, nearly there are 14 responses, more than I think nearly none of them don't know. So I'll explain it nowadays. All right, thank you. I think I got more than half of the classes responses from the half of the class. Yeah. All right. Well, okay. Now let me share my screen. I think before going to the subject, I should what we got, give some sort of overview. What are these memory and other stuff? Uh, so I'll share my screen. So most of you know what is RAM and RAM size. So the secondary storage, it might be a little bit confusions for you. So the best thing is I just want to explain what is this secondary storage. Secondary storage is nothing, the place that you can store. As an example, you might see my secondary storage. I have nearly 686 gigabyte of F1 plus 243 plus 237. So altogether 125, 100 and 100 and sorry, 1 gigabyte and 250 storage nearly, right? 1 gigabyte, and because these together it's nearly 1 gigabyte, and here it's nearly 250, right? So why it happens? Because my C drive is a SSD card. It's a separated. So I don't know whether you have SSPs and other stuff. I don't know. Right? So somehow this is the storage. So all these three are storage. So simply we can say, all right, these are the secondary storage. Primary storage is the RAM. RAM is mainly focusing to support to the processor. So it provides support for the processor to process stuff. But the storing, whatever the files and other stuff stored in here, right? So the stuff is stored in here, but processed in the processor. Before moving to the processor, it should get the help from RAM to process this stuff. So simply you might see, all right, this is just like a library. It's just like a set of libraries, physical libraries, books are there, the books are stored in there. So these libraries kept a lot of files, books, newspapers, and other stuff. Similarly, these places store a lot of things. But if you borrowed one book, that means you are going to process it. So before you process it, you should borrow it. So what is the place that borrowing? It's the RAM. Right? So that's more than enough for this understanding for this. I'll come to virtual memory later on, but before that, we'll go to little bit stuff. So, well, now we're supposed to discuss today this memory management and the role of operating system. Right? So, operating system provides very dramatic support for this work performed by this hardware layer. Now, the memory management is to ensure that processors are allocated memory as required. That means, speaking strictly, it's your RAM. To ensure processes are allocated memory. So it should be allocated to the memory as required, because finite memory of physical memory. You want to see your physical memory, you may just tell it's your RAM plus your storage, secondary storage. Now you know what is the secondary storage. So these two together usually known as, there are some other components, but in high level, you may just tell, all right, these two are the physical memory. So if somewhere you just found, all right, what is the physical memory? You just tell it's just RAM and the secondary storage. It's more than enough to for simply explain to someone else. Lack of memory can stop processes from running, because we'll get an example. Your RAM is 4 GB. Your RAM is 4 GB. Your RAM is 4 GB. Now, think a situation. I think, yeah, well, nearly half of the student, half of the percentage of students having 4 GB RAM, and nearly half of them having 8 GB RAMs. Now, this is a finite amount. This 4 GB is finite. It's not infinite. It's not unlimited. It's a specific amount. So what happens in here, your 4 GB, all the processors are trying to access this 4 GB. By before process, it should be moved to 4 GB. That's the theory. Now, think a situation, 1000 processors are trying to move, 1000 processors are trying to move to RAM. We'll get an example. Each process requires 1 megabyte. 1 megabyte. So altogether it's 1000 megabytes required. 1000 megabytes required. We can assume, right? So we'll assume. Okay. What happens in here? Is there any problem will occur? Any issues in this case? There are 1000 processors. Each process required 1 megabyte. Altogether 1000 megabytes required. My primary storage is 4 gigabytes. So that means nearly will take, nearly it's 4000 megabytes. 4000 megabytes. Is there any problem? Is these processes can run parallelly, simultaneously? Any issues? Valid processing? No idea. Simply say yes or no, that's fine. Yes. Now what is at all? Can process. Good. Now we'll get another situation. There's not 1000, it's 10,000. It's 10,000 means requires 10,000 megabytes. So nearly 10 gigabytes it's required. Now what happens? My physical memory, or my primary storage, or the primary processing point, or the RAM in generic terms, it has only 4 gigabytes, but the required is 10 gigabytes. Now it's a big process. Now it's not sufficient. Your primary storage is insufficient. It's a big problem now. So what happens? After 4000 processes arrived, the rest of the processes needs to be stopped. Isn't it? Why it's 4000 processes? Yeah, I'm just getting very high level, very what we call very high level numbers. You may calculate it more finite level in future, but it's just I'm giving very high level values. It's just 4000 megabytes are there. So altogether no worries at all. 4000 processes can be allocated because each process required 1 megabyte. So 1 megabyte multiplied by 4000 processes is 4000 megabytes. 4000 megabytes. But 4001, now I don't have sufficient space. Plus 1. Another one, there's no sufficient, there's insufficient. We don't have sufficient space. It's a big problem now. That's why we are telling it's a lack of memory can stop processors from running. Now everyone trying to jump to the place. Now the processes are getting stuck. That's the biggest deal that we have to solve now. You got the point? You got the question? If memory do not manage properly, definitely computer will corrupt or stuck every time. Every time. That's the situation. Now we'll see. There are different allocation schemes. There are like how the memory allocation and other stuff, but I'm not going to discuss that. But we'll look into this virtual memory. What is this virtual memory and why this virtual memory is required? How much this virtual memory is important. Other functions related to the operating systems, like memory management related to by operating system, translating virtual addresses to physical addresses in RAM. So it might be quite confused. I'll just tell what is happening here. Now, I think still none of you are staying in a hostel or a board. All of you are staying in your home, but near future, once the university started, you will back to the universities. So you can't travel each day. So you have to stay nearby place. We'll take an example now. Someone is Bandaranayagamawatha, this place. But your actual location is Kandy, this place. Pallekala, Kandy, this place. Now, someone asked from like your friend, you're asking, all right, what's your address mention? Then what's the address that you are giving? You're giving your physical address, not your virtual address. Why? It's just temporary address. It's not a permanent resident. It's just a permanent address. It's just a temporary. Got the point? Now, what happens in operating system? It's exactly same. Your data is stored in a place. Stored in a place, in a specific place in your secondary storage, your C drive or a D drive. Now, what happens in here? That data requires to move to the processor to process. It requires to move to processor to process, unless it can't process. Now, operating system knows where you actually initially located. Now it took it out and let the RAM, okay, please process this guy. I mean, process this guy means ready for reading. Ready for reading. Read this book or something. This is the actual location. Or the now here you might just say it's a virtual address. Virtual address. Initially you are in Kandy. Now you are in a virtual place. And this is the place that you are actual things are happening. Okay, that's the virtual address to physical addresses. Now there are a lot of things, a lot of math behind the scene. I don't want to go that much deeper, but generic understanding is more than enough. Ensuring that processors cannot access memory belongings to other processors, managing shared memory. Now, ensuring processors cannot access memory belong to other processors. Now, it's like one person is going to stay in here and someone is trying to access the same place. Now it's a conflict. To avoid this conflict, what happens usually? There's a specific registry to store. What is this registry? Don't get confused. It's just a set of values that we keep a record. As an example, where you temporarily store or temporarily located your hostel place or something. There's a specific room number, room 8, room F7 or something. There's a specific room number you are staying. Actual story might be different because university is providing a specific number. You might stay whatever the place that you want. That's a different story. And regardless of any other thing, you just stay the preferred bed that you want. That's not something you have to countable in here. But that's the reality. But once it comes to the processes, it won't move here and there like that. It moves the proper place initially given. If we access for all of these things, what would be happen now? That's a big problem, a big issue. Managing shared memory. There are situations that shared memory. It's like sharing same address space. I don't want to go that. Well, that's more than enough. All right. So these are the other functions that under the memory management, which is performed by the operating systems. Any questions? If you are understanding, it's a big problem for me. If this is the first time, if you are understanding everything, it's a big problem for me. Any questions? Anything else? Let me explain it again a little bit. You're still getting confusions. Not sure whether. Now, I think this portion you got. Is that so? Up to now, up to this portion, these concepts, you got it. The process always you should understand the physical memory is a specific or a limited memory. If there's insufficient memory, then the processes can be stopped. And for allocating these processes, there are different schemes. You may learn it self-study or something nowadays at all. And under this subject area, we just going to understand virtual memory. And what are the other functions related to the operating system, or what are the functions that operating system is going to be responsible or is responsible? Translating virtual addresses to physical addresses. So it's just like a temporary residence and your permanent residence, where you temporarily live and your home. All right. So it's a translation. Someone should be translate, unless it might be the same place, might be different people access. Right. As an example, again, if we tell, all right, these are the virtual addresses. 0x1234, 0y 1234 and stuff. And again, if there's another guy who is willing to access this virtual address, it's again a big problem. That's why we are ensuring the processes cannot access memory belong to other processes. Whenever there's a process allocated, that's it. We can't move back and forth. Managing shared memory, how the shared memory is going to be managed. So basically, if you have some basic understanding, that's more than enough. If not, go a few times and go additional resources, definitely. If not, this might be quite confusing, especially the guys who are coming from business, so the commerce background. Maths, I think you just understand at least up to some level. IT guys, no worries at all. You can understand this quickly, but for the other sections, the other stuff might be a bit hard. This is one of a high-level diagram that you should understand. Memory request queue, whenever it requires some sort of memory spaces. As an example, this requires 4 megabytes, and this one requires 2 megabytes, 1 megabyte, and 3 megabytes, and so on and so forth. There are memory requirements are there. Now what happens here, it moves pool of memory allocation. So there are specific a range. This is 4 gigabytes of space, and in this 4 gigabytes of space, it's going to be located in different locations according to the availability. These are the allocated blocks, and these are the free blocks. In any case, if your memory is full, your 4 GB is full, that's it, you can't move further. Well, we'll come to this virtual memory. Uses virtual or a logical address that doesn't correspond to physical memory locations. Memory management unit does translation of virtual to physical addresses. We'll see what happens in here and what is this virtual memory and why we need this virtual memory. After learning this, you might change your machine, your computer. Let me change your life. Now what happens in here? Now this is your physical address, your physical memory. It's 4 GB. This is your secondary storage. We'll take it's 500 gigabytes. It's 500 gigabytes. By comparing these two, and even like for anyone, easily can understand. All right, this requires 4 gigabytes. This requires 500 gigabytes storage. This is a temporal storage, which is helping to process. What happens in this 4 GB? What happens in 4 GB? It's ready to process. Here, it's ready to store, ready to process, ready to store. This is your C drive, D drive, right? E and other stuff. You have partitioned it to different names. Now, our main problem occurring because of this 4 GB space, because it's insufficient. It's obviously, you can understand, it's 4 GB is insufficient. If it comes to 1 megabyte per process, if it comes to 4,000 processors, my computer will get stuck. Any solution for this problem? I want to expand this 4 GB to take 10 gigabytes. I want to expand it to 10 gigabytes. The condition number one, I don't have money to allocate a physical RAM. I can't purchase a physical device, and due to some configurations or any other reason, I can't plug it for some reason. Ports are not available for some reason. It's just 4 GB physical space should be used. That's the condition that you have to use. Propose method that you can solve this problem. I want to enhance this 4 GB to 10 GB, but not by physically. How can I expand this 4 GB to 10 GB? That's an interesting question. How to solve this problem? The first student will get a chocolate. First correct answer will get a chocolate. After starting the university, you can contact me and grab this chocolate. ඔයගලන්ට මගේ ප්‍රශ්නේ තේරුණා නේද? මගේ ප්‍රශ්නේ තමයි මගේ මේ memory එක 4GB තියෙන්නේ. මට මේක 10GB කරගන්න ඕනේ. හැබැයි physical space එකක් සල්ලි වලට ගන්න බෑ. මට RAM එකක් සල්ලි වලට ගන්න සල්ලි නෑ. සල්ලි නෑ. හරි machine එක වැඩ කරන්නේ නැහැ. මොකක් හරි port එකක් නෑ. හරි මොකක් හරි case එකක් තියෙනවා. මට ඕනේ මේක solve කරන්න. කොහොමද මම මේ 4GB 10GB කරන්නේ? That's the question. Yeah, well, good answer. Use virtual memory. I just want to clear explanation. What is this virtual memory? How it happens? Yeah, perfect answer. Virtual memory. Problem solved. Perfect. What is that? How it works? How to solve this problem? Mathematically. Yeah. All right. Sorry. Right. I got different answers. Yeah, well, good answer. Purchase some space from hard disk. Perfect. Well, temporary stand RAM to secondary storage. Perfect. Good. Right. Now, how to solve this problem? I want 10 GB, but unfortunately, my physical memory is 4 GB. But fortunately, my secondary memory is 500 gigabytes. 500 gigabytes. Why we don't use this 500 gigabytes? What's the problem? Because this secondary storage do not supposed to run as a RAM. It's a secondary storage, it's a storage place. So we can store the stuff. All right, we can store the stuff, no worries at all. We can store. All right, we can store the stuff in here. Well, what I'm going to tell, okay, from this 500 gigabytes, could you please give me 6 gigabytes? You give me 6 gigabytes. Why? Whenever there's a process is going to be processed, I'll use this 4 GB. If there's the resource requirement, or now you should understand, you should the diagram should come into your head, right? This is the running process, this is the new, right? This is the place that hold, this is the place that processes are hold, right? So this is the complete diagram, right? So keep it with you forever unless you can't understand most of the stuff. So here, this is the place that we can temporarily store some sort of processes until the resources are fulfilling. It's a halt. So what's my plan? My plan is, whenever some process going to be halt, I don't use this 4 GB. Instead of, I'll use this 6 GB. Perfect. Isn't it? It's a perfect solution. Now, whenever something needs to process, nowadays I'll take that 4 GB. Whenever it interrupts, whenever some resources are not fulfilled, some insufficient resources, it's in the process, it's in the waiting queue. So all the waiting queue can be moved to your secondary storage, because it's a storage. It's not a problem at all. So by combining this 4 GB plus 6 GB, by combining these two, let me take, right? This 4 GB with this 6 GB altogether, now I have 10 gigabytes. Perfect, right? It's a perfect solution. Whenever something going to be processed, it uses 4 GB. In any case, if it is in the, this is the process state diagram. Okay, I think it's in your head. Please make sure to memorize this diagram. It's mandatory. Whenever, if you don't memorize this process state diagram, you can't learn operating systems at all. That's the first theory. You should memorize it. There's no option for that. You should memorize. So from this 4 GB to 6 GB, altogether it's 10 GB. But this 6 GB will use whenever you want to store it temporarily. It's not used for processing. It's just temporal storage. As usually, secondary storage is for storing. No worries at all. It's stored. Perfect. Perfect. No worries at all. I'll store it. But here, this 4, it's fully allocated for processing now. What is the major problem that we have initially? It's 4,000 megabytes needs to access. All right, now I'm giving access, no worries at all. And if in any case it needs to store or temporarily halt or waiting queue, I'll move it into the place. This space is known as virtual memory. This space is known as virtual memory. Now, once it comes to virtual memory, it's not a fixed. We can allocate a fixed virtual memory. Obviously, that's fine. No worries at all. We can allocate a fixed virtual memory. But is that a valuable or a proper solution? Or shall we keep this virtual memory dynamically allocated? That means on the fly. Whenever there's a requirement only, it can be expand or shrink. What is your idea? Shall I keep it fixed or dynamically? What is your idea? What do you think? Shall I keep it fixed, or shall I keep this space dynamically? That means this 6 GB can be vary. Like if there's a requirement, we can expand it to 10 gigabytes. If there's no requirement, I'll shrink it to 1 gigabyte. Or shall I keep it fixed as a fixed asset or a fixed size? It's 6 GB. What is your idea? What do you think? Any ideas? Any comments? Any thoughts? What do you think? What should be the proper method? You can. Both approaches are allowed, no worries at all. But what's the best? Not fixed. It should be dynamic. All right. I got one answer. It should be dynamic. Any others? It might be right or wrong. No worries at all. I don't get upset at all. Virtual RAM is static. Well, what's the meaning of virtual RAM is static? Hmm. Can you please little bit elaborate on this? Aging. Oh, bit advanced. Well, aging is bit advanced. I don't want to go to that level just now. The question is, my 6 GB can be kept as it is. That means my virtual memory is 4 GB. It's fixed. It's a fixed. Or there's an option that I can vary. I can change the size of this virtual memory to 1 GB to 2. We'll take 20 GB. According to the situation, if required more space, if don't require, we can shrink it. What should be the approach? How can we solve this problem? What's the best approach? Quick, guys, quick. Don't waste time. Quickly. What's your preferred method? There are 31 students just now. So quickly, you can say it's dynamic or static, or it might be a fixed size, or it might be dynamic size. Consolidation. All right. Well, um, what's the meaning of this consolidation? That means you just try to combine these two. All right. Somehow. Good. It depends on the story, right? It depends on the story, actually. But usually, when it comes to Windows, we allow to keep it dynamic. But if you want, you can keep it fixed. You can keep it as a fixed asset. As an example, you can keep fixed 10 GB or 12 GB or something. There's option. We can keep it dynamic, or we can change it. Yeah, one student is suggesting it's 1 point size of our RAM size. So that's a nice mathematical interpretation. So what we required is 1.5 of the size of RAM size. That's a nice interpretation, but don't stick for that. But don't stick for that. It might vary. It's not like there's no mathematical proof 100% it's accurate. Right? So shall we do a small practical? Now, what I want to see from you is to find your virtual memory of your computer. Now, you know what is virtual memory. Theoretically, you know, that's good now. Now you should be able to find your virtual memory size. How to find this virtual memory size? Shall I give a couple of minutes to try your end? And shall I present, or shall I directly show you how to find it? Best is having more pain from your end, right? I'll give five minutes around maximum. Quickly, you may find it and share it as a privately, but see your size or dynamically allocated, or it's not statistically statically allocated. Quickly find. Anyone found your size, your virtual memory size? Well, I got an answer. We'll see quickly. Well, not actually. All right, let me share my screen and show you uh, how to find the size. All right, what we can do. I'll share my screen quickly. I think I need to share the entire screen. Yeah. All right. Then give me a second. I just want to because I want. Well, I will share the screen quickly with you. Where is it? Share. All right. All right. I think now you can see my screen. What I'm going to do, I'm going to press Windows key. Then I'm type to system information. I just type system info system while it's typing it can identify the system information. Once I click this system information, I'll navigate to this page, which is the system information representation. In here, you might see all of these valuable information like your operating system version and other stuff, your processor even. Little bit down, you might see this information. Installed physical memory, your RAM is 8 GB. And this is my space. For your one, it might be different. Total physical memory 7.81 gigabytes. That means the usable physical memory is this much. Available physical memory, how much remain I can use. So these are the physical memory related stuff. Then after you might see total virtual memory. In here it's 9.21 gigabytes. It's total virtual memory. Available virtual memory 3.63 gigabytes. Now this much of virtual memory I have, and this is the available memory. For your case, it might be different. Different sizes might be available. Quickly check what's your total virtual memory and the available virtual memory. Quickly chat, have a share your answer with me in the chat. Not with all, just individually with me. How can I do? Quickly press the Windows key, system information. Just click the system information, then you'll be redirected to this page. All right, click. Yeah, I'm getting answers. Good. All right, thank you. I got good enough answers. Now you know how to find your virtual memory. Who's supposed to control this virtual memory? Operating system. Now, if any case your operating system gets stuck, confused, your virtual memory get into trouble. So that's the importance of this virtual memory. I'll come to the last but not least most important one later on. Before that, well, shall we change this virtual memory, the size of the virtual memory, or what is the current settings of my virtual memory? Let me share my screen again and show you how to find this or how to modify my virtual memory size. Let me share. Okay, I'll share the screen. Right, I think now, yeah. Now you can see my screen. What I'm going to do, I'm going to press my Windows key. I'm going to type system settings. Settings. Once I move to settings, I'm just trying to performance. All right. Once I type performance, adjust appearance and performance of Windows. I'll click here. It redirects to the performance option. And in the advanced tab, you might see virtual memory. The paging file in this area, hard disk, Windows users, blah, 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 blah. And total paging size of all devices, I'm going to change it. All right. So I have given fully authority to automatically manage paging size of all devices. I have given, all right, you change it according to the requirement. What I'm going to do, I'm going to untick it. Now it's enabled. Now manually I can change it. Whatever the stuff, if I required, I can change it to custom size. So it's not recommended. Personally, I don't recommend this process to change these to manual configurations. But if you really interest, you may do it. Nowadays at all, nothing will happen. You can go back and forth and change it according to your requirements. If you really fear, you may keep some screenshots before doing the modifications. Then if you got confused, nowadays at all, you go back and check the initial size of the allocations. You may change it nowadays at all, but the best is always keep it automatically. Then hassle-free process might be there because operating system Windows take all the responsibilities related to the virtual memory management. So we don't want to bother too much, but if you require, if someone asks, shall we change the size of virtual memory? Obviously we can. What's the device drive that you want? C, E, or F. For my case, I don't have D, but if your case, you might be C or D something. So you can change it. You can change the current available spices, and the total minimum allowed is this one, and the recommended is this one. Current allocated is this one. So whenever if you are going to change, you might get some different values. As an example, you can say the initial size is 10. We'll see what happens. 10. Maximum size this one. I'm just going to set it. Then you are telling must be between 16 megabytes. That's why I told the minimum allowed is 16 megabytes. You saw it, right? If I'm going to change it below that, it's getting an error. So I told it's the initial size of my memory is 10 megabytes, but minimum allowed is 16. And they are giving an error exception or an error message. Sorry, you can't perform this one. So it's interesting. You can change it time to time. You can enjoy it nowadays at all. Nothing will happen. At the end of the day, just tell it's automatic. Then click OK. That's it. All right. Restart your computer. So I don't want to restart for now because I'll get into a problem. So I'll keep it as it is. All right. I just want to cancel it. Then nowadays happens. All right. Try it. Now it's your turn. Check whether you can do this modification and check the dynamic is that dynamically allocated. If it is not, My recommendation is always keep it dynamically allocated. Then no worries at all. It's quite easy. If someone got stuck, let me know. I can help you. I'll give another couple of minutes, not a long time. I have shared the path if someone got confused to move. Settings, performance, in the advanced tab. Just go to the settings, then type performance, then type advanced. Click advanced. Right. I think it's more than enough. Well, little more. Anyone got confused? Any questions? Any problems that you faced? Yeah, there's a chat. Caching. Well, caching is a different mechanism actually. It's not the virtual. Once it comes to your memory, there are three layers: L1, L2, L3 caches. Let me. Caching is not something related to this, but if you are interested, I'll show you. Anyone having any other question? Anything else? No other questions? Everything is okay? All right, let me share my screen, then you can understand this caching. Just a little bit out of this operating system discussion, but if you're really interested, I think that's good to show you. Share the screen. Right. Now I'm in the task manager. All right, I'm in the task manager. I think you can see my screen. All right, I'm in task manager. How to go to task manager? Just type, press the Windows key, then type task manager. Then you can go to task manager. There are shortcuts, but I'm not going to present those things. But somehow, if you go to this performance tab, under the performance tab, if you click this CPU, you might see in here L1, L2, L3 caches available. So these are temporal storages. Again, caching is a temporal storage, which is very important to run the process. The very nearest process, or the most nearest component to be stored in these caches, L1, L2, L3 caches. Usually L3 is the largest and L1 is the smallest. It's just kilobytes of size, and L2 and L3 caches are there. So all of these caches are located in CPU. Now, up to now, you have learned what we call primary and secondary storages. But again, L1, L2, L3 caches also storages, but it resides in CPU. It's not resides in memory. You should understand, right? So the memory, there's a cached memory available. It's not something L1, L2, L3 caches. These cache means a component. It's a hardware specified location that available in CPU to process the next instruction or the next process. Memory is not that. In here you might find this cached. That is the memory space that keep for future references. If any case if required, then we can use this cached memory. That's the difference in here. In CPU, this L1, L2, L3 caches are there. This is the place that memory, and these are the disks that I have. SSD, that my C drive, my SSD disk, and this is my hard disk drive, HDD. So you might see since my SSD is working, my hard disk drive is not working at all. It's just 0%. But if you don't have any installation of SSD or something else like that, there are different implementations. If you are not using that kind of thing, you might have only HDD, and there's a graph in here because there's a process is going on. Clear? I think that's more than enough for a small discussion, but there are a lot. There are a lot. If you are really interested, you can learn a lot. Right. Well, we'll go to the discussion again. We stopped here. These are very practical subjects. You do it with the hands-on experience. I don't asking for a become as a computer scientist. It might be out of your scope, but having some basic understanding related to the computer world, that's very important. Then you are in a secure stage, regardless of the job. Right. Well, now I think you got fully understanding what is this virtual memory, where it locates, and how the sizes are defined, to how to view the size, and what is the importance of this virtual memory, and how it creates, and everything detailed information in your head. But who is doing all of these things? It's operating system. So operating system's responsibility is to manage the virtual memory properly. Why? The physical memory is something defined by the organization that created or originally created. Your RAM size is originally defined as 4 GB or 8 GB or something else. And your hard disk drive, your secondary storage, it's defined. It might be 500 gigabytes or something, 1 terabyte or something. It's defined. But this virtual memory defined dynamically by the operating system. That's the importance. So why we want this virtual memory? Very first question, all right, fine. We solve this problem. Why we want? Because our 4 GB or 8 GB RAM is insufficient. So we want to expand it dynamically, but we don't want to physically implement anything. So what we supposed to do, we supposed to implement a mechanism or a method that we can take the secondary memory that can support to our primary memory. But unfortunately, secondary memory can store. So the problem solved. How? By the processes. Whenever there's a process that is in a waiting queue, we push all of these things into the virtual memory. Now fine, and the problem is solved. Virtual memory stores all of these unwanted stuff, unwanted processes, or hanged or not running or waiting in the queue. Right now, well, that's the story of this virtual memory. One more thing I want to add to yourself. Now, you might get a problem like once you are growing, your machine is growing, especially your downloads folder is growing very fast, isn't it? Your C drive or your downloads folder most of the time. Let me share my screen, then I think I can much easily explain the story. All right. I think now you can see my screen. I'll go to my machine, and this is my PC. All right, here. This is my C drive. Why this C drive is quite important? Because this is the place that my operating system resides, or installation happens in here, not EOF. How can I easily understand? Because there's a Windows line. Okay. Now, this is the place that my C drive or my operating system resides or installed in this C drive. It's not in EOF. Now, think a situation, my C drive is getting full. Right? After these downloads and other stuff, it's getting full like this. And my F drive is full now, almost full. It's just 5 gigabytes free. It's full. If it happens, for F drive, it's not a problem at all. But if it happens to the C drive, happens to the C drive, what happens in here? My C drive is getting fill. Okay, 230 gigabytes full. Now your operating system getting stuck, slow, not working stage, blurred stage, different issues are there. If your C drive is getting full, if your C drive is getting a little bit full, it's a big problem. Your computer might be getting definitely slow. It's 100% guaranteed. Sometimes there might be some stucks. Your computer is getting stuck after your C drive is getting full. Now, what is the reason behind that? Now you should be explained why it happens. What is the reason behind this? If your C drive is full, your machine is getting stuck. But not happens for E or if now. In my case, if it's full, almost full, but no issues in my machine, it's working perfectly. If my C drive is full, definitely I'm getting a lot of problems. Think your machine, your computer. Now open your computer and check whether your C drive is full or not. If it is full, quickly take all of this stuff into some another drive, E or F, some another drive. Can someone explain why this situation happened? Why this machine is getting slow? No answers. Now you should be able to interpret it. Just now you have learned something, virtual memory. Try to apply into this story. What happens in here? No answers. All right. Well, what's the reason behind your computer getting slow? Because your virtual memory allocated from this C drive. If your C drive is getting full, now it's getting filling. Now it's full, almost full. Now there's no option, no place to take additional space for virtual memory, because virtual memory allocated from your C drive, not from the others. It allocated from C drive. So your C drive is full. There's only, we'll take as an example, in this case, my C drive, it's telling 237. Almost 235 C drive is full. 2235. Only 2 GB available space. Now, where the operating system is trying to extract or take or allocate virtual memory, from where? I don't have space. Operating system is telling, I don't have space to take. My drive is full, because operating system always trying to take virtual memory from C drive. So if it is getting filling or it is almost full, it's a big problem for your machine. Definitely your machine is getting slow. One of major consideration, as per my experience, is students are downloading into the downloads folder. Downloads folder is located in C drive. So you can see, if I click here, yeah, C drive. So all of these places are the key places. Right? C users, well, I think it's HP. Now you might see my downloads. This is the place that my downloads happen. Due to that reason, I don't think even that, but unfortunately it's collectively storing, continuously it's storing. Clear? After a while, my C drive is getting filled, now getting slow because insufficient virtual memory. We got the question, how to solve this problem? Easily cut all of the stuff into another drive. My recommended method is change your downloads folder into some another drive, not related to C, something like E or F or something, D, E or F, something that you have partition, it's up to your case. Right? That's the best thing that you can do. Then most of the cases might be solved. Clear? Any questions? Anything needs to clarify? Well, there's a problem. If you have installed only C drive, it's a biggest mistake that you have done. Partition it to C and D at least. If you are using C drive, means your hard disk drive always it's processing unwanted spaces also. I think you learn these sectors and other stuff. Your well, give me a second. I'll use my PowerPoint slide to explain that. It's a biggest mistake. Don't do that. Always have at least another space, additional space for that. Here, this is your hard disk. If you allocate entire hard disk for C drive, this is the entire C drive. So every time your head, this is the head, right? So it's spinning continuously, it's spinning. So your head always spinning. If you have partitioned into two or more, what happens in here? This is your disk. There's a space for C and D. This is your C drive, this is your D drive. Now it spins, or the head always needs to keep in touch only this area. No need to check all of these things. Then your computer might get faster than usual, and storage might be much organized than just having a C drive. If you have only C drive, there's no option. The best solution is partition it to C and D and work on it. There might be different alternatives, but for now I can't recommend those alternatives. Sometimes you might know about some more advanced methods like to solve these problems, but most of them are not official recommended methods. All right, that's the story of virtual memory. Any questions further? Anything needs to clarify? Well, if you don't have any questions, I have to give a question. Well, I think you know about my point schemes, right? So I will give another 5 points. I'll share one question. Then you can grab another 5 points. All right, I have shared the question. All right, it's more than enough. Quickly submit. I just got only 2 responses. Please don't copy paste. No point at all to copy paste because this is not for marks. I told you that. I told you whether it's correct or not, just attending is more than enough. I'll keep the links enabled even after this. Uh, so please make sure to explain in your own words. Don't try to copy paste. No point at all. Quickly, please. I just got only 7 responses, at least 10 to 12. Quickly. Don't take a lot of time. All right, still I got 11. Well, why is that so hard? If you got hard or confused nowadays at all, later on you can go through and talk a little bit further. All right. There's a one answer that not much good that it's telling virtual memory is part of secondary memory that is used to exclude. So, well, though it's a generated from secondary memory, it's not a component of secondary memory. Like it's just some sort of what we call an area. Right? It's an area. It's not a component, it's just a specified area. It's a virtual area, that's it. Clear? So you should specify those things, unless it might be a bit confused after a while. All right. Well, any questions? Anything needs to clarify? Check. There's a check. What is that? I'm not sure what is this question that for the in-class activities that we are doing. Not sure what it is that actually. So the links are enabled for like when after the lecture you can use it, no worries at all. If you want to share the links in the Moodle, I'll share it, no worries at all. Though it's telling it's in class, no worries, after the lesson you can submit it. That's not a big deal, and no marks allocated. It's just set of points only. So don't worry. If you miss it, nothing will happen to you. But attending for those in-class activities, you might get an additional opportunity to get a high score by adding these points, because my quizzes are quite hard. So most of the students get around 2 to 3 marks out of 50. So the best thing is attending for these things, then might get much opportunity. All right, it's just some sort of motivation and additional help to you. All right, not sure if you want a little bit further. Ask me any question, I can help you. All right, but We'll go to a little bit further. I don't stop these responses. You can submit it later on even nowadays. Okay. There's a message from your instructor, Miss Deepani Kaushalya. She's telling that there are 3 students who missed the in-class assessment, and you should stay until you should not leave, right? You should not leave. You should stay in this lecture even after the lecture. Then you can. Then she will help you to complete this test, makeup test. Right? Did I convey that message properly, or depending you can tell the students what you want knowledge at all?
So those who missed the in-class assignment, please don't leave after this lecture. Thank you so much, sir.
All right. All right. We'll move then. Let me share the screen. All right. Here the translation. Now, memory unit does translation of virtual to physical addresses. Now, I don't want to go for these physical addresses just now, but after the paging, you will understand what is this translation of physical virtual addresses to physical addresses. So memory broken into blocks called pages. Now we'll take an example here. Here some sort of memory. We'll take an example of 4 GB RAM, take very high level, 4 GB RAM, and now this 4 GB RAM can be divided into small pieces, very small pieces. Usually it's kilobyte size of. So what happens in here, we are allocating around, we'll see 24 kilo size of kilobyte. Its size is 24. Well, think this is a book. Now these are the pages. A book consists of number of pages. We'll take 200 pages. Each page has a specific size. That's why you are getting a big book at the end of the day. If not, you might get a very small. There are different sizes and same size. I think the cover page, it has a much width than the others. Width in the sense the depth of the page. Now, similarly, the computer does the same thing. There are different sizes and the same size, both having. Usually, if he is speaking high level, it's just the same size of page, 24 kilobytes. It's just given a random number. Don't get upset unless you might think, all right, a page is 24 kilobytes, not at all. It might be 48 or it might be 64. Right? It depends. The page size is depends. It has different sizes. Now, these components, these small components known as pages. These are very small components. These are known as pages. By reading all of these pages, you might find a specific component which is known as your memory. I have divided memory into a little further component known as page. If need more RAM space, some pages copied, swap out to secondary storage area known as subspace. Now you should understand, all right, here my RAM, 4 GB RAM. I have 5,000 processors comes into the storage. Okay, 5,000 processors are there, but unfortunately I can't allocate now. We'll assume 1 megabyte for each process, so it's 5,000 megabytes altogether. Now all the 5,000 processors are trying to access, it's concurrent or simultaneously it's going to be processed. But my physical space is 4 GB RAM. Now it's a big problem. How to solve this problem? Well, we discussed it. We can allocate a virtual space or a virtual memory. That's perfect solution. Some pages copied, swapped out. That means now think my 4 GB, all the 4 GB RAM is full. What we can do, some of processors, like we can temporarily take it out. Now think a situation that you have 3 assessments to be completed today itself, midnight last time. No more extensions. Lecture is quite hard, very bad guy. No extensions at all. Now what happens in here? You have to give up for one because you can't complete all 3 together. So what you want to give up. You kept it for future. I'll repeat this subject and I'll do it in next year or next semester according to the availability. Swap out, take it out, but the information exactly same as the previous. You just copied your textbook, your other related learning materials and whatever. It's just copied out, swapped out. Similarly, what happens in the computer? There's a 4 GB RAM, it's full now, we can't solve it. 5,000 comes, okay, so out no option. What I can do, I can take 1,000 megabytes out to the RAM or virtual memory. It's your idea. To the RAM or to the virtual memory. Quickly. To the RAM or the virtual memory. No, well, you should now quickly tell. It's not a big deal now. You know what happens? No space. We can't access to the any other place. The only available space is my virtual memory. So the subspace is a special component. It's a special component. This special component resides in the secondary storage. Now, well, where this subspace is, that virtual memory, what's the interconnection in between virtual memory and subspace? Yes, yeah, it's quite easy. You know now, subspace, it's a portion of virtual memory. It's a component or a space or an area that's in the hard disk usually. This is a special case when the RAM is full. When the RAM is full, we swap it out. But there might be some disadvantage too. What's the disadvantage? By having this, another thing. These pages can be swapped in again when required now. I took it out for temporarily. Right. It's temporarily because I don't have sufficient space. Now space is available back again. Then I can take it up. This process is this taking out is known as swap out. This process is known as swap in. So it's obvious. So it's just temporary storage. Right? So basically, now what happens in here? There's a big advantage. We can overcome this physical space problem, and the biggest disadvantage is it requires a time, because all the time what we are supposed to do, we take it out and take it in. Think a situation, it requires 1 millisecond, 2 milliseconds altogether for the entire process. So it's a big disadvantage one is as it comes to computer world. It might be not a millisecond, it might be nanosecond, but think 1,000 nanoseconds. Again, it makes your computer slower. And the other biggest disadvantage is processor can't directly access. Why? Give me the answer quickly. Processor can't directly access. Why? What's the reason behind that? Processor can't directly access. Yes, why? What is the reason? Yeah, I got answer. Yeah, perfect. It's secondary memory. It's in secondary, it's secondary memory. So processor can access only for the primary memory. Perfect. Ravindu, right? Give a big clap to Ravindu. So the processor can't directly access because this swap space is a special component in secondary storage, which is like a special area which is known as our virtual memory, swap space. So swap space can't access, right? So sorry, processor can't directly access to the swap space forever. It's just enabled to storage. It's a temporary storage again. Got the point? Got these dots together, connected, clear? Anything needs to clarify further? All right. There's no questions nowadays at all. We'll go a little bit further. Now it's here. You might see it's a diagram what happens in this story. This is the virtual memory. This is the physical memory, and this is the disk. All right. So virtual memory can access here and there nowadays at all. Here you are, processors, memory, blah 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 blah. Lot of things. All right. Any questions from this up to now? Don't keep questions in your head. Throw it to me. If I can solve, I can solve definitely. If not, I'll check and solve you. No worries at all. Probably I can. Well, no questions. Everything is okay. Right. You know the RAM size, so I don't want to keep this practical just now. Anyone needs to, anyone needs my help to find the RAM size? If you don't know, you can, what do you call it? You can press your Windows button, then type system information, then you might see. I think I have shown you it a little bit earlier, the physical size there, RAM size, isn't it? So I think you can. Any questions? No, right? Everything is okay. Clear? Sorry. We completed memory management. It's very high level discussion. If time permits, definitely I'll go another round and do some mathematical calculations. Very interesting mathematical calculations are there, like page size related stuff and others. But I know for a first year student it might be a big like task to complete those things, so I have minimized the risk from your end. We'll see if we have time. We'll definitely go more advanced concepts and solve very nice problems related to this page size and other stuff. All right, you see. Next, file and disk management. This is one of very important concept. We'll go. File, named collection of data, normally resides in secondary storage. Normally, have specified it's normally, it's not all the time, resides in secondary storage. There are situations that files are stored in primary, but later on, not now. Some operating systems have an extension allows to do DA type of files. So Unix, DOS, Windows, especially if you are a Windows background, you might see these kinds of like, what is the type? Different names are there. CSS, HTML, Java, C, exe, zip, lot of extensions are there. So you might see file extensions here. Directories of folders, the hierarchy or the structure that elements are stored in a computer. It's in the hierarchy. So C, under the C drive, different folders are there. Inside a folder there's another folder, inside that folder another folder, inside another folder, and finally you might store some information in a folder. Inside this folder there might be some more information. Likewise, these things, it's very basic. Now the operating system is responsible to do this management, to manage these location. Where it actually resides in your computer, this is your hard disk drive. Inside this hard disk drive, there's a specific location, there's a specific flow to move to this path, this place, specific place. Right? Starts from some another place, it's move, and move. All right, this is the place. It's a logical structure. There's a specific hierarchy, specific flow to move to that place. If not, it's not a proper place. There might be orphan files. Sometimes you have heard these orphan files. Some files do not have any connection. Especially, you might see some like programming. I don't know whether you are much familiar or not. There are like objects are creating some files. It's like it's not a file actually. It's an object. Memory objects are creating. Dynamic objects are created. Then there are like garbage collector. There's a concept called, I don't know. All right, ignore that. If we go that level, you might get confused. Somehow, you just understand this is a file, this is a directory or a folder. That's more than enough for now. This is a logical drive, and this is the hierarchy of the logical drive. You might see extract, same thing in here. Now, file attributes, I don't want to go to this one. now. We'll go it later on this file allocation table and other stuff, how the memory is going to structure these files. But for now, we'll see. So the file attributes, file size, writable, writable, read only, etc. Have you any experience with this read only files, write only files? You can read it only. You can't update. You can add any text to these files. Yeah, once you join to, like, especially once it comes to computer world, I don't know whether you are much familiar with these things or not. There are servers, there are specific locations that we can access a file, specific file. This might be just a Word document thing. It's just a Word document that remotely located. If you can't understand that thing, you just understand it's just a shared Google Drive, Google Doc. It's a shared Google Doc. You can't edit it. You can view it. You can view it. Do you have this kind of experience? You can't edit that file. You can't do any modification. You can just view it. Any other thing you can't do. Do you have such experience? Even in Google Doc? Anyone? Yes. All right. Well, good. Let me share my screen and show you if you don't have this kind of experience. Sometimes you don't know and you keep quiet forever. I have created a Google Doc. I think you can see my screen. Okay. Well, once I click this share, what is this? Share. Here, I can change what are the things that a person can do with the link. I'm just telling it's just a viewer. If you have this link, you can view it or you can comment it. You can't edit the text in the file, but you can comment it, no worries at all. And you are an editor, you can modify the text. Okay, all right. Now I have modified as an editor. As an editor, I just did. All right. Well, I'm going to share the link with you now. I have shared the link with you now. Now you can edit the stuff in this file. Here I told it's goodbye. Can someone please edit this text? Add another text, your name or something, your email address or whatever. Don't worry, it's just anonymous. Don't worry. Just say hi, or something. Just try to edit. Try to whether you can edit it or not. Add a text. That's it. You can. No worries at all. Yeah, you can. All right. You keep doing that. All right. You keep doing that. Keep adding these things. Now what I'm going to do, I'm going to change it to editor. Right. All right, now try it. Can you see? Right? Some text added, right? Some text added, but it's not added to the original text. It's just telling, all right, something can accept or not. See the guys who type in something in here. Say hi. If I want to delete, I can delete. Now there's a guy, Niti or Niti say hi. Now what I'm going to do it, I'm going to reject the suggestion. That's it. Now hi is not there. Got the point? Now, well, we'll do another small modification for this. Get these hands-on experiences. Now in the chat, open the comment history, you might see these chat, what happens in here and there. Okay, well, what I'm going to do, I'm going to change it a little bit further. Just a viewer. Done. All right. Now try to do some modification. What happens? What happens? Try to add your name or something. Sorry, it's me. I can. What about you? I can. What about you? Try to add name or any other thing. It's blocked. Simply it's blocked. Now this document is view only. You can view it. No worries at all. You can view it. You can read it, whatever the stuff in here, but you can't do any modification for this document. Now, if you want to share some valuable information with someone else, if you want to block the different security levels, this is how you have to do. Now, in this case, this Google Doc hosted in a cloud environment and it's controlled by cloud operating system. I don't want to go to that level, but you just understand similarly, same thing, nearly same thing, we can perform in a computer too. Nearly same thing. The readable, writable, write only and other stuff, we can set up our computer, the documents that we are sharing, we can let it, no one can read it, or no one can write it, no one can edit it, no one can modify it. Why I took this information in here, the Google Doc? Well, if I share a document read only, there are methods, there are softwares available, and there are different operating systems that allow us to modify. If I share a file, you might come up with the answers. So no, there are options. So to avoid that, I just got Google Doc and state you what is this readable and writable. You can comment it, you can read it, or you can edit it. There are different stages given by Google Doc. Similarly, operating system has full authority to provide these kinds of modifications, or provide secured environment or blocked environment for the end users to perform some sort of modification, or not to perform any modification. Clear? To perform modification or not to perform modification. File system manages physical storage of data on secondary storage drivers, maps logical file structure to physical storage. A single file may be distributed blocks in drive. So ignore this module 6. We'll come to these modules later on. Different operating systems may have different incompatible file systems. Now, well, if you have any experience in Linux related one, as an example, Ubuntu. There are different file types available. It's incompatible in Windows. You can't open it. You can't open it in Windows environment. And some Windows environment files you can't open in Ubuntu. Anyone having this experience? Anyone used Ubuntu? Not at all. No worries. Now, give me let me give an example for you. Especially exe files, executable files, exe files. These are running in Windows environment. But exes are not executable in Linux environment. Got the point? Different operating systems have different incompatible files. Exe files. It's incompatibility here. There are .sh files. These sh are not working in Windows environment. Anyone with a MacBook or a ProBook or something? Have you tried to execute these exe files, sh files in your Mac? What is your experience? Can you install software as it is, exe files in Mac? Can't run. Can't run. It's incompatible. Operating system do not allow to execute these kinds of things. It's blocked. Once it comes to Ubuntu or a Linux environment, this is one of major concern. There are insufficient softwares to run. I don't feel any other major issue use Ubuntu or some sort of Ubuntu, any Linux distribution. The major blocker is insufficient softwares. When it comes to Windows, we do have very large amount of softwares, a collection of softwares, especially for graphics and other stuff. But once it comes to Ubuntu, we don't have that much of sophisticated softwares. That might be the organizational goal, because Windows is focusing for generic or normal people, but Ubuntu might be focusing on developers and specified set of people, like Mac, like Apple organization. Like Apple is targeting for only for specific set of people. They don't consider all over the world. They just consider the top niche people, top 10% or top 15%, the highest economical range. They don't focus on the others. That might be the reason. I don't know the business concept behind the scene, but that's the core reason that I felt. For you, it might be some different, right? So this is a file system. You know, different file systems are there. A lot of different file systems are there nowadays at all. And here, file system also manage application, user request for file, open, save, etc. Apps use system calls, which is discussion for later on. I don't want to disturb you for now. I know it's a big problem if I start with the system calls just now. It's a big problem for you. So it's just a call. As an example, if I want to call, hey Ravindu, then it's a call. It's a specific call. I'm specifying who I need to access. Then Ravindu will say, hey, hi, how are you? If I want to say Manori or something, I don't know. Users do this via utilities, file managers, or user interfaces. There's a specific component that we're supposed to discuss under this user interface. It's quite detailed. Access control. permissions to file. Can a user read a file, write it, delete it, etc.? Link to the security functions of operating system. Now, some of files we can specify. No one can delete it from that location. Sometimes you can hide the files. There are softwares even that we are trying to hide it. No one can access for these files. Even you can't see there's a file in this location. If you open relevant software, you can open that specific file. Unless that you can't do any modification. You can't find anything. Clear? There are different access controlling mechanisms. Well, I don't want to come to that just now. There are user access control levels too. All of these controlling mechanisms supposed to block users. It requires to block specific set of users, not to do these kind of things. It might be modification, it might be addition in the sense editing. It might be totally deletion. It might be recreating a file, copy and paste. We can. Do you have any experience that your browser even do not allow to copy some stuff in a web page? Anyone? No experience. All right. Somehow, especially once it comes to web development, there are specific files we do not allow access unless if it is administrated. No one can access. It's totally blocked. Because most of the attacks are happening because if you open these files to the environment. What's the meaning of this environment? Environment means the place that hosted or stored. Usually it might be a web server or a web location, or some sort of server location. In generic terms, it's a server location. Disk management includes partitioning, dividing a physical drive into multiple logical drives. Now, what is that? Physical drive. We do have only one physical drive. This is your hard disk drive, your HDD. This is the only component that you physically, if you take it out, you can't see your C drive or D drive. It's a physical drive, a physical space. That's it. You can't do anything else. You can't do anything else. But this physical space can divide into different components or different spaces. We are renaming these spaces as C drive, D drive, E drive, etc. Why we have logically partitioned? Make our life easier. That's it. That's the major concern from end user's perspective. But from the technical perspective, it's much easier because the hierarchy of the data is much easier to manage. Think if it is a tree structure, as an example, in a specific folder, well, we say C drive, then, admin or user, then inside here, there's documents, right? In these documents folder, there's a specific document, a.html. This is the hierarchy. Think if we do not have C, D, and E, what we should do, we should keep all the files in a different set of names. So all the time, the processor requires to check whether none of them are working or all are activated. It's a big problem. And in the other hand, if it is a one big folder is going to be maintained, the hierarchy of the folders are too deep. The files might be requires to go C users, blah, 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 blah. Finally, it finds each and every point. Your computer has a specific processing power. It requires a specific processing power. Now, all of these are big problems. To avoid all of these problems, what is the proposed mechanism? Partitioning, dividing into different components. But those are not physical. It's just virtual. As an example, while once the first time that you are installing your operating system, you can tell, all right, C drive should be 200 gigabytes and D drive should be 800 gigabytes. That's it. At the beginning, you told. After a while, even if you want to partition it, you can partition it. It's not a problem, but highly not recommended. Why? If some data crashes, you can't back up it, because operating system is not responsible for that backup. If you want to divide into 3 or 4, even 5, no worries at all, you can. But the recommended is maximum up to 3. Don't go beyond that. Why? When it comes to too much divided into physical logical components, your computer needs to manage another file, another table. It's out of my discussion from today. So it's a big problem for computer. That's the reason we do not divide more than 3 partitions in real world situation. Span volumes. Combining multiple partitions, hard drives into single logical drive. You can combine, as an example, you are using currently C drive, D, and E. I think these are the partitions that you are currently using. After a while, if you want, you can change or you can combine these E and D together, and we can tell, all right, no more E alive, E is gone, now it's D. Or simply you can say not D or E, you just tell it's F. That's what happens to my D drive. Now it's not in there further, it's gone. It's gone. Have you seen? Not D drive in there. There was a D drive time back. Now it's not in there. It's gone. Now just E and F. That has happened to me. If you want to have these funny experiences, do it. No worries at all. No one will die. That's the important thing. Don't worry, maximum your computer might crash. You just install your operating system again. That's it. I'm pretty sure you are not using a licensed version. So no worries at all. Even if it is 1,000 times crashes nowadays, install your operating system again and again. Nothing will happen. No issues. Not good for your computer, that's okay. After your graduation, you will definitely sell your laptop and you will purchase a new one, a very sophisticated one somehow. I have discussed mainly two key terms today, partitioning and span volumes. So partition is dividing into multiple, and span volumes is combining multiple partitions and creating a single logical track. Any questions up to now? Anything needs to clarify? Anything you needs to add? Any clarifications? Any questions? Yes, seems there's a question. No, or everything is clear. All right. Others? All right. No questions. Everything is clear. All right. If you don't have any questions, well, I think it's not a good time to move to another topic. Instead of we'll do small activity. Yeah, well, we do it later on. Next, it's a small activity to do, but I think we don't have much time. Yeah, just 5 minutes. No need to that. But well, don't leave now. There are three guys who needs to wait, isn't it? So please, you three guys, stay here. And for the others, I'm sharing a question to you. So please share your honest answer with me, because then I can do some modifications, because this is a totally technical subject that I'm going to teach. I'm teaching now. Sometimes you might get it, sometimes not. So I'm not sure whether you are getting or not. I know few of you are getting, some of, I don't know whether all of you are getting. I know, I'm pretty sure I can't teach for 100% students, but at least like 70 to 80% students should be get at the end of the day, unless there's no point at all. I mean, just for the students who are attending. I don't want to bother about the people who are staying at home just for fun. Students who join into the lecture, I should care about you. That's what I think. So please share your reflection, your personal reflection on this. And that's all for today. Before leaving, make sure to keep a note in here. Well, I'll share it. And I don't know, Deepani, it's up to you now. Others, see you. Bye bye. We'll meet next week, and we'll continue the session. I think all the slides are uploaded, or I mean the complete slide deck is uploaded. You can go through and come. All right. See you. Bye. See you. Bye bye. We'll meet next week. Well, Deepani.
Yes, sir.
Yeah, you can continue the questions or something that you have for the students. I don't know.
Okay, thank you, sir. Please wait those who missed the in-class assignment. Others, please leave.
There are 8 guys, right? Please leave that. Apart from that, 3 students required. Who are the students Deepani needed?
Sir, I didn't know index number, but there is 3 students.
Oh, any of you? Lavanya is here, and I don't know the names are there. Can you please raise your hand with the? Are you guys just hang on or keep the recording up and left? How do you know? Please switch on your mics and tell yes or not.